I'm Kevin Quinlan, and today we're going to be looking at how to produce ethanol using fermentation, and then how to produce higher concentrations of ethanol using distillation. Now, this is important because ethanol has a number of uses, including in industry. It's used as a solvent of perfume manufacturing. It's used in a fuel as fuel in gas, like when you see 10% ethanol in a gas, at the gas pump when you're fueling up. And ethylene is used for the manufacture of plastics. But today I'm going to focus primarily on producing ethyl alcohol because, hey, it's just fun. The pop culture reference I used is from a show called Moonshiners. It's from an episode that aired January 29th of 2020. The clip is about a minute long, and in the show, for those who don't know, the show is about people who live in the Smoky Mountains region and produce moonshine. In this episode, one of the men goes to Ireland to see how Irish whiskey is made. Irish whiskey, they do it a little bit different. They triple distill things to make it smoother. And the factory this man visits uses huge containers called stills that contain about 5 tons of copper each. This clip shows how to distill alcohol on a large scale, but the principles I'm going to explain will work on big and small scales. Before we begin talking about distillation, I'm going to explain some of the chemistry behind how ethanol is produced. So the chemical equations below summarize the fermentation of sucrose into ethanol. As you can see, alcoholic fermentation converts 1 mole of glucose into 2 moles of ethanol and 2 moles of carbon dioxide, producing 2 moles of ATP in the process. And here's the chemical formula right there. So in the first step of fermentation, the enzyme inverterase cleaves the glucose and the fructose molecules. In this case, we've got sucrose here to create glucose. The next step of fermentation is when each glucose molecule is broken down into 2 pyruvate molecules shown here. So, and this process is known as glycolysis, and it's summarized by this equation here, where you've got glucose and ADP goes into pyruvate and ATP. Now, finally, the pyruvate is converted to ethanol and carbon dioxide in 2 steps. And once again, the chemical equations are there, and so it's broken down into ethanol. So that's fermentation right there. Now, everything we've been talking about so far is kind of the chemistry of how ethanol is created, but I'm going to explain how to physically do it. So all ethanol contained in all alcoholic beverages is produced by fermentation of yeast. So beer, whiskey, vodka are all produced by this fermentation, including yeast. And the process is called making a mash. So creating a mash, what you do is you get all your ingredients together. You get your water, your grain, and you put it together and you steep it at 68.5 degrees. So that's going to get the amylase at just the right temperature to get the most sugar out of there. And the more sugar you can get, the more ethanol you can break down later. And once you have that all done, that's when you add the yeast, which will actually go ahead and ferment the sugars. Now, fermentation does have some limits. It can only bring alcohol to a concentration of about 15% of volume to volume. So to make higher alcohol concentration, which once again is important not only if you want to get drunk quicker, but if you want to create any of these industrial uses, you need to use distillation. So distillation works because of the difference in boiling points between ethanol and water. Ethanol's boiling point is significantly less than water's boiling point. So what you want to do is put the the mash that you have together, which is the ethanol and water together, and you want to heat it at approximately 78, 79 degrees Celsius so that all that gets converted into boiling point is the ethanol and the water's left behind. So how it works is when you distill, the boiled alcohol vapor rises out of the boiler, and the vapor runs through a copper tube, and then this tube is surrounded by cold water, which will cool it down quickly and cause it to go from a gas condensed back into a liquid state, where it goes out through here and collects. And at that point, you got the choice of drinking it right away, like the moonshiners do, or you can age it to do things to make it smoother. Now, important thing I want to mention is even just using distillation, the process will never get 100% of the alcohol. Highest purity you can get is 95% of just the ethanol alone, and this is due to hydrogen bonding between the ethanol and the water. So even when you convert all the ethanol into gas and the steam, some water gets trapped because both of them are polar. And it's also important to note that this is a physical change, not a chemical one. You're just changing from a liquid state into a gas and back to a liquid. You're not actually changing any of the chemicals themselves. Anyway, thank you very much. I hope this has been really educational for you. It's been fun for me, and have a great day.